photosynthesis saturates out early, so the plant can't take up nitrogen if the CO2 isn't there commensurate to meet the requirement of the metabolism. Because taking up nutrients is a metabolically depleting process. Then we're going to change our farming practices to be carbon oriented. Because it's not just NPK, it's CNPK. That's the difference.
Sebuah daerah di Pierre, South Dakota. Kita akan menuju ke Dakota Lake Research Farm untuk menemui seorang peneliti lapangan bernama Dr. Dwayne Beck. Dia adalah manajer pertanian di sini. Dia akan menjelaskan tentang filosofi pertanian yang sudah mereka jalankan sejak tahun 1990.
In the systems approach, what we're doing is we're using basic ecology principles to try to decide how things work. And that comes down to why you look at the native vegetation first. And that tells you what you can do where you're at. But to use Mother Nature's system, it's an approach of trying to fit in with what the system's going to allow you to do rather than trying to make the system do what you want it to do. I mean, the idea is how close can we get to mimicking the natural ecosystem in terms of how we cycle the nutrients, how we harvest the sunlight, how we cycle the water. Living soil is one of the things that's on the sign. The outcomes are what we're really looking for. We can't get to that outcome with no-till alone. We can't get to that outcome with cover crops alone. We can't get to that outcome, in my opinion, with rotations that aren't diverse, which everybody wants to do, because, you know, I'm a corn grower. Well, I'm a corn grower too, and I grow wheat, and I grow teff, and I grow peas, and I grow lentils, and I grow flax, and I grow soybeans, and I grow sunflowers, and right? We do all those things. The point is as farmers, the diversity gives you lots of advantages. Economic advantages that you don't necessarily see unless you're doing them, because they save you all this money if you figure out how to take advantage of the system. Technology is good, but technology is there to augment good management and not to replace good management. You know, and what Mother Nature says when we throw technology at her, you know, it's kind of like the old movies. You know, the guy comes up and just whaps this big guy, and he looks down and goes, yeah, okay. And that's kind of what's happening. You know, we're trying to do all this stuff instead of saying, okay, she's got all these systems out there. You know, I grew up on a farm with watching my grandfather and father, and actually a lot of the technique we use goes back to some of those techniques that they use that probably had gone down through centuries of development, some of the concepts, and I'm not sure they knew exactly why they were doing some things, but I got inducted into the South Dakota Hall of Fame in 2007. Basically, that's what I said, is I'm getting inducted into the Hall of Fame for rediscovering things my grandfather and father did. Yeah. And bringing them back in and putting a twist on that we're going to do this now in a modern context with not doing tillage. And the only thing we ever did is we just took old ecological principles of crop rotation and predators and prey, and we haven't used an insecticide on the farm here in about 10 years. Yeah. You know, and if we screw it up, then yeah, we have to come in and take a big bat and hit the reset button maybe, but we haven't had to do that now in quite a while. And you know, the way we do the insect thing is we're very, very cautious about using insecticide, because we learned early on, as soon as we pull that trigger on an insecticide, then we kill the predators. Our entomology friends tell us we have about 2 billion predators per acre. Okay. With a B. And some of them are ants, and then one of the main causes of death of things like aphids is fungi.
Right.
So if you have a very active fungi population there, I mean, they give the heebie-jeebies to the aphids when they come in.
Yeah.
And there's really good evidence of that. I mean, there's good numbers, good real science that people have proven that. I mean, we guessed that.
Yeah.
At one time based on principle.
Sesuatu yang ironis mengetahui masih banyak petani yang belum atau kurang memahami tentang pentingnya arti karbon bagi tanah. Bahkan sebagian besar petani atau orang pada umumnya justru menganggap karbon adalah sesuatu yang buruk. Dr. Will Brinton akan menjelaskan hal ini kepada Anda.
I tell people there's no such thing in soil as C, carbon. It doesn't exist as carbon. It exists as organic matter from once living material, detritus that's decomposing. And you can't see it here, but there's humus all through here that has carbon in it. 50% of humus is carbon. The rest is hydrogen, oxygen, and some minerals, nitrogen in particular, and then phosphorus and a little sulfur, bound up in this complex molecule. But here's what I'm saying about carbon. It's really, you have to see it in the active sense of being carbon dioxide. Well, when I say carbon dioxide, you say, oh, there's CO2 in the air, and that's what all the climate change discussion is about. But these soils are producing CO2 from the carbon. It's not a chemical reaction. It's a biological process. Microorganisms are feeding on this organic matter right here and turning it into nutrients for the body and releasing the C as CO2, which is coming up here, diffusing up through the soil. The beauty of the CO2 relationship is that what's the primary requirement of a growing plant that absorbs sunlight?
It's going to be carbon dioxide.
That's correct. Without the carbon dioxide, no sugars are formed, and the whole infrastructure of plant metabolism doesn't happen. So we naively think, oh, plants are just getting the CO2 from the air. But if you think dynamically, the CO2 is coming from the soil. And this is a great canopy here to show it. These are rich soils. There's a high activity. We've measured the respiration rate in the soil. We can quantify that now as CO2 per acre. That's what's getting really exciting. This plant canopy has a very high CO2 demand during full growth, probably in the order of 50 to 100 pounds of CO2 per day while these radish plants are at full growth. Where is the CO2 coming from? Well, isn't it convenient? It's being produced right here in the soil, and it's bubbling up out of the soil, so to speak, by capillary and diffusion, going past the water molecules and soil particles, and the plant leaves are grabbing it and recycling it immediately. So the humus, it was humus 1 minute, next hour it's CO2, another hour later it's synthesized sugar in the plants, and it's on its way back down into the soil. Carbon dioxide requirements can be quantified, and I believe we will find that there's evidence that canopies during full growth are CO2 limited, and what that means is photosynthesis saturates out early, so the plant can't take up nitrogen if the CO2 isn't there commensurate to meet the requirement of the metabolism. Because taking up nutrients is a metabolically depleting process. It's not a passive process. So it's a whole system. And I think as we begin to quantify CO2, we're going to have some astonishing discoveries here in terms of crop yield limitations. And then we're going to change our farming practices to be carbon oriented. Because it's not just NPK, it's C-NPK. That's the difference.
Ini adalah penghujung dari bagian ketiga. Bagian ini sekaligus menjadi penutup seluruh serial video ilmu pertanian Amerika Serikat. Semoga seluruh serial video ini memberi manfaat bagi Anda yang telah menonton. Terima kasih.